Welcome, everyone. Welcome back. Thank you for being here today. So we're going to do part two of our med calculation series. Last time we reviewed some basic med math, basic formulas, conversions, how to read labels, some medication administration rights. So this time we're going to go into the meat and bones of med math. Okay, so our introduction to medication calculations. So here's our learning objectives. It's pretty short. Part one has more. You could add these to your first objective. We're going to understand the steps of dimensional analysis. We're going to have understanding of drip factors. And again, set your goal to practice, practice, practice to mastery. Okay, so now let's go into the steps. So first, we want to identify what the problem is asking. We want to see what the provider ordered for our patient, okay? That will be our vehicle. That will be our answer. Then we're going to identify the drug label. Our second component is any conversion factors if we need it. Then we're going to add our MD order, and then any other factors. I know it's a little confusing, but just remember the sequence. Our availability of drugs, conversion factor if needed. If we don't need it, the next step would be our MD order and any other factors. So we have our drug label. We have ciprofloxacin, 500 milligram tablets, and the provider ordered 1 gram PO every 24 hours for the next 5 days. We have our conversion. We know 1 gram equals 1,000 milligrams. It comes in tabs. We're gonna give tabs per dose. So the key thing is to match the tab, whatever units is in the front will match the first step on the back. So our availability, in every tab, we have 500 milligrams. That's our first, our drug label. Second, a conversion factor because we need one, right? So now that you've matched the first red tabs together and then milligram go in the bottom, now everything that's on the bottom will have to match the top, would have to match the subsequent top. So our conversion factor is 1,000 milligrams is 1 gram. The next line, so we have 1 gram overdose. We have no other factor. Now we're going to cancel out any like units. Grams cancel out because they match. And then what we have left is tabs per dose, which matches our initial vehicle. You're going to multiply across and then divide across. In your calculator, you're going to say, you don't have to put 1,000 divided by 500, and then you're going to get 2 tabs per dose. Yes, this is a example you could have did with desired overhand. It seemed pretty easy, but this is just kind of the appetizer. We're going to get into a more complex example soon. So now we're going to look at a dimensional analysis example without a conversion factor, okay? Here is our provider order. Your patient is diagnosed with pulmonary embolism. He's going to need a heparin drip. So the order is for 25,000 units of heparin in 500 ml, and we're going to infuse that 1,200 units per hour. That's what the physician ordered. So the question is, what will be our rate in mLs per hour? So that's what they're asking for. So our first step, and here's our IV bag. Our first step, they're asking for mLs per hour. We're going to put mLs per hour as our first step. The next step, the first line must match the top of the first line. 500 mLs match, 500 mLs, 25,000 units. Always remember to keep your components together. If it's 500 milligrams in a 100 ml bag, you keep it together, the mLs with the units together, okay? So what goes on this top? It's gonna have to be units, which is our doctor's order. So 1,200 units, and he wants it going over an hour. Can we cancel anything out? Yes, we're gonna cancel units, and what we have left is mLs, and we have hour, which matches what they're asking for. So your answer is 24 mLs per hour. So this one is gonna incorporate more factors such as weight and time. Our order is to infuse, they want IV infusing at 5 mics per kilogram per minute. Your drug comes in 500 milligrams in 250. The patient weighs 80 kilograms. Now, how many mLs should this patient receive? They're asking for mLs per hour. We're going to put mLs per hour. That's your first step. Second step, our drug availability, 500 milligrams in 250 mLs. So let's put that on top. We know our mLs match. And after that, every subsequent unit is going to match from top to bottom or bottom to top. And next is our doctor's order. So as you can see, the units do not match. The doctor ordered in mics and our availability is in milligrams. So we need a conversion factor. So the conversion from milligrams and mics is 1 milligram is 1,000 mics. So now we could put in our provider order, which is 400 mics per minute. How did we get 400 mics? Well, the patient weighs 80 kilograms and the order is for 5 mics per kilogram. So if you do 80 times 5, you'll get 400. So it's 400 mics for each minute. So are we done? We need mLs per hour. We don't have any units that say hour. So our next is another conversion factor. We're going to switch minutes to hours. So 60 minutes equals 1 hour. All right, so let's cancel out any like units. And then we have left mLs and we have left hour. That's how you know your your problem is complete. You don't need any other factors. You're going to multiply across in your calculator. You're going to 250 times 400 times 60. And then you're going to divide that by 500 divided by 1,000. You could do it in one shot, which I find easier without pressing the equal sign in between. 250 times 400 times 60 divided by 500 divided by 1,000. And you should get an answer of 12 mLs per hour. Awesome job if you understand this. I want to show you a second option. We did our calculation of the weight outside and we put it into our problem. So let's see how we could do it without doing any outside calculations. So here's our second option. You have mLs per hour. Availability is 250 mLs over 500. Our conversion factor, 1 milligram over 1,000. Our order, 5 mics over a kilogram over minute. A patient weight, 80 kilograms. And the time, 60 minutes per hour. So you could see everything will cancel out. And then you'll have left mLs per hour and you should get the same number. So this is the option of not doing any other outside calculation and putting it into your problem. Okay, so we're going to get into some IV calculation formulas. So any resource that you use have different formulas for IV calculations. We have a 3-step method, which will give you the mLs per hour. We have formula for drips per minute. We have 2-step methods and there's 1-step method. If you are comfortable with any of these, please feel free to use them. These formulas are included in our resources below, but the one thing I do like about dimensional analysis, and it encompasses all of the formulas into one problem that you could use. So we're going to do any IV practice using dimensional analysis. What is a drip factor? Before we get into drip calculation, IV calculation, you kind of have to know what a drip factor is. So we have micro drips and macro drips. And that basically refers to the diameter of the needle in the chamber of your IV line. So an IV drip factor reflects the size of the drop of the fluid IV line or that tubing creates. Each IV line has a predetermined set of drops that can go in a minute, okay? So a micro IV drip creates a very small drop, as you could see on the left, and a macro creates a large drop. Micro drips tubing are very precise, and it's used for very sensitive drugs, and it's mostly given in the neonatal units, okay, for pediatric patients. So if you see a IV tubing and it says 60 drops per ml, that is a micro drip. Okay, 60 drops per ml, that's micro dripped. Macro MA is our standard tubing. Okay, this is what you're gonna mostly see. Um, and it delivers about 10 to 20 drops per ml. You'll also see, this is where you could see your drip factor right in that blue corner of your IV line. Okay, so 10 drops per ml, macro drip, micro drips, about 60 drops per ml, very small drips, very precise measurements. And this is going to be you in a few months calculating your drips. All right, so let's practice using this. So we have an order of 1,000 mLs of D5.5 normal saline to go over 6 hours. The availability is 1 liter of D5 normal saline. And the IV is labeled 10 drips. So you pulled your IV tubing and you have a 10 drip per ml, which is our standard macro drip. What is our drips per minute? So they're asking for drips per minute. That's going to be our first line. So remember, the top line has to match. The first two top lines have to match. Usually that's going to be our drip rate, the tubing. So 10 drips per ml. Next, we're going to add our order. Our order is for 1,000 mLs, and the provider wants it going over 6 hours, 1,000 mLs over 6 hours. Okay, are we done? We could cross off mLs, but we still have the hours because we need minutes. So we need one more factor. 1 hour, excuse the S, 1 hour is 60 minutes. So now we crossed off mLs, we crossed off hours, we left with drips, we left with minutes, and that's what they're asking for. So we know we're done. So let's multiply across and then divide. Now we have 2.7. And then you're going to remember you can't give a fraction of a drip. So you're going to make it into a whole number, which is 28 drips per minute. Try another one. So our provider ordered clindamycin, 500 milligrams IV every 12 hours, and they want that infused over 30 minutes. We have our solution and set, 100 ml bag, and then you pulled out your IV tubing, and it's 10 drips per ml. Okay, so here's a clindamycin 600. So we're going to take that medication, put it in that 100 ml bag. Okay, so first step is, what is the drug dose? How much are we going to put into that bag if you're mixing your own medication? Second question is, what's the flow rate? What is the drips per minute? So for the first step, you could use your desired overhand to calculate how much medication you're going to give. You're going to do 900 over 600. They're all in the same units times 4, because our availability is 600 milligrams in 4 mLs. And then we have 6 mLs. So you're going to draw up 6 mLs from that vial, and you're going to put it into your 100 cc bag. Okay, so now let's calculate our drips per minute. We have drips per minute. The first step have to match. Let's put in our drip factor, our drip, which is 10 milligrams per ml. And then our order, they want to go in 100 mLs in 30 minutes, okay? mLs crossed off, we are left with drips, we're left with minutes, and our answer is 33 drips per minute. Yes, you did it. All right, let's try one more. And I have the answer there already. So, but let's go through the exercise. So the client is prescribed 650 milligrams of Tylenol liquid. The pharmacy provides the mixture of 500 milligrams per ml. How many mLs of medication will the nurse provide the client in a day, in the whole day? How many mLs of medication in a day? So it's mLs per day. That's going to be our first step. Next step is we have 1 ml, 500 milligrams. That's our availability. Second step, 650 milligrams over dose. And then we have 4 doses per day. So please note, we're not given per dose, we're given per day. So remember that the medication is given every 6 hours. So there are 4 6 hours in a 24-hour day. So it's 4 doses per day. So let's cross off our milligrams. Our doses are crossed off. We're left with mLs per day. And yes, we're going to give 5.2 mLs per day. How is that? Do you guys see that? Yes, I see it too. Awesome job. Okay, you would take your 650 times 4 divided by 500, and you're left with 5.2 mLs. Okay, so here's I think this is our last practice exercise. Our order is for cefaclor, 20 milligrams per kilogram per day in 3 divided doses. So the order is per day, you're going to divide that into 3 doses. The child weighs 20 pounds. The drug is available at 125 milligrams in 5 mLs. How much are we going to give per dose? So if it's not specifically stated of how much per day, how much per dose, just know you want to know how much you're going to give at that point to the child, not a per day dose. So we have mLs per dose. The availability is 5 mLs over 125 milligrams. The units match, so we don't need a conversion factor. Our doctor's order is 20 milligrams per kilogram per day. The child weighs 20 pounds. So we need a conversion factor for the weight. So notice I'm going to put 1 kilogram over 2.2 pounds. The child weighs 20 pounds. And remember, you're matching from bottom to top, bottom to top. The milligrams are crossed off. Kilograms are crossed off. Pounds are crossed off. Okay. And then we need dose, but we have day. So we need one more conversion factor. 1 day is 3 doses. Now we're able to cross off day, and we have mLs and we have doses left. We know we are complete. So if you multiply across 5 times 20 divided by 125 divided by 2.2 divided by 3, you are left with 2.4 mLs per dose. You got this. You got this. So please watch the video again if you, but there are more practice questions. Look in the description box. If you need a review of conversion factors, watch part 1 of our MedCalc videos, and then review again part 2. As you can see, dimensional analysis, you're able to go from the easiest problem to the most difficult and complicated problems as we reviewed here. So I am so happy you were able to sit and practice with me, but go practice until you hit mastery. And please don't forget to like, to subscribe, to share this with any nurses, any future nurses that you know, your colleagues, your friends, and press the notification bell so you'll know when another video is coming out. See you soon. Hey, yo,